Rust 1.75.0 was released today, December 28th, 2023, thanks to the hard work of hundreds of contributors. Let's dive into the new changes. Number 1, just as I teased in my video earlier this week, you can now use async fun in traits and return position impl trait in traits. Let's explain that last one first. You could already do return position impl trait in functions. For example, this function can return anything that implements an iterator that iterates over immutable references to color structs. But until Rust 1.75, you couldn't take that function and make it a method of a trait. So here I've tried to define the color collection trait to have a colors method, which takes an immutable reference to self and returns something that implements the iterator trait over immutable references to the color struct. And then I tried to implement that trait for a slice of paint. This now works in Rust 1.75. Because this works, async fun in traits is now also supported. This means you can define async methods in traits like this. So here we have an async method fetch, which returns an HTML body. What does this have to do with return position impl trait in traits? Async fun is syntactic sugar for a method which returns an impl future trait. So now you can see why return position impl trait in traits enables the async fun feature as well. Some words of advice. At this time, users can't add additional bounds to the return type. This will be supported in a later release, but for now that means you shouldn't use these features in public traits unless you are certain your users will not need to add bounds to the return types. Go ahead and use them in private traits all you want. Also, dynamic dispatch is not yet supported for these features, though it will be added in a future release. You can keep using the old async trait attribute way of doing things for now if you need dynamic dispatch. Finally, there is a trait variant crate with a make macro, which will add the send trait to the bounds for your async methods, enabling using them in multi-threaded runtimes like Tokyo. This should also become unnecessary in a future release. For more details, see the link in the description below. Number 2, there are pointer byte offset APIs for raw pointers that have been stabilized. This would normally be down in the Stabilized APIs section, but this was a headliner in the release notes, so it's up here at number 2. Raw pointers like *const_t and *mute_t have methods like add, sub, and offset that operate in units of the size of t. This means that before Rust 1.75, if someone wanted to do operations in single byte units, then they would first have to cast the pointers to U8, and then call the methods after that. In Rust 1.75, there are 7 newly stabilized methods that operate on individual bytes so that you no longer have to do that awkward casting. On Linux, on 64-bit x86 platforms, the Rust compiler itself is now about 3.5% faster due to some optimizations applied to building the compiler itself. Hopefully, these optimizations will expand to a broader set of platforms in the future. Number 4. Function pointer signatures may now contain mutable references in const contexts. For example, here is a const function which returns a function pointer to a function which takes a mutable reference to a string. Before Rust 1.75, this mutable reference would have caused a compiler error. Now it works, and we can return string clear. Number 5. This is an interesting one. You can now exhaustively match usize and isize integers with half-open ranges. The weird thing about usize and isize is that on some platforms they can have values above the max, or in the case of isize, below the min, because for usize and isize, these constants represent limits of allowable pointer and object sizes, not the mathematical maximums and minimums. Platforms can, and sometimes do, choose to set these values higher or lower than you would expect. So before now, if you wanted to match on ranges of isizes or usizes that extended to maximum or minimum possible values, you had to use a wildcard pattern and combine it with an if expression, which is kind of awkward when the whole point of a match expression is to replace a bunch of if expressions. You can't just match on a range to the min or max because, again, on some platforms there are valid values for usize and isize beyond the min and max constants. So this would require adding the wildcard and if expression combination to catch those. Anyway, what we want to do is match on half-open ranges that go past the min and max constants. And now, in Rust 1.75, we can. Number 6. it is now guaranteed that the char type has the same size and alignment as the U32 type on all platforms. I think this was already the case in practice, but now it's a documented guarantee. Number 7. It has now been documented that the raw pointer referred to as null in unsafe Rust APIs always has the address 0. Everyone already expected this, but now it's documented and guaranteed. Number 8. Partially moved values are now allowed to be matched on as long as your match pattern ignores the moved parts. For example, I have defined here an array of 2 widgets. To demonstrate this principle, I could have used any type that is not copy. A widget will do just fine. Next, I match on the array and examine the first item in the array. Since this is not a copy type, this moves the value out of the array. So now the array has been partially moved. Next, if I try to match on just the second item in the array, Rust 1.74 would see that the array has been partially moved and would stop and emit an error. Rust 1.75 has learned how to check and see that the pattern only looks at the parts that haven't been moved, so it works just fine. Number 9. This release adds documentation about why it isn't possible to implement fully compliant floating point behavior on a large number of 32-bit x86 targets. It just isn't possible on some hardware. 32-bit x86 is just the worst. I can't believe I grew up using that stuff. Number 10. 19 of the RISC-V target features that have been ratified by the RISC-V Foundation have been stabilized. This means Rust 1.75 is even nicer on RISC-V platforms than before. I love the idea of RISC-V, but I'm not sure I've ever encountered it in person. Have you? Number 11. The compiler internals that deal with negative coherence now properly consider implementations that only partly overlap. I couldn't figure out what this means in terms of real code. So if you understand what's going on in this one, please comment below and clue me in. For now, I'm just going to assume that the compiler works even better when it's dealing with overlapping generic implementations. Number 12. Remember that co-inductive overlap in coherence lint that I talked about in the Rust 1.73 video? Yeah, I didn't really think you'd remember. Anyway, it was worn by default, but in Rust 1.75, it switches to deny by default. For more details about what the lint checks for, go check out my 1.73 video. Number 13. The compiler now considers alias bounds when computing liveness in non-lexical lifetimes. In practice, this means that the compiler can know something is safe to borrow in a few more situations, increasing the ergonomics of borrowing. Number 14. The RISC-V 64 Linux Android platform now requires the vector extension to be supported on the RISC-V processor in question. This is a Tier 3 platform, so major breaking changes like this are allowed. If you happen to be running Rust on Android on a RISC-V processor that doesn't support the vector extension, then you're simply out of luck. Time to upgrade. Number 15. The compiler now automatically enables cross-crate inlining for small functions. This will result in faster code at the cost of slightly increased size of compiled binaries. Number 16. There are 3 new Tier 3 targets. The first is Linux on another Chinese C-Sky processor, only unlike the C-Sky platform introduced in Rust 1.73, this variant has a hardware floating point unit. Next, we've got a version of NetBSD aimed at the old AMD Geode embedded system on a chip that is instruction compatible with the venerable Intel Pentium. The AMD Geode hasn't been updated since 2009, according to Wikipedia, but apparently they're still being used. Last, we've got NetBSD once again, only this time on a 32-bit Little Endian MIPS processor. NetBSD sure seems to be living up to its reputation of running on all sorts of odd architectures. Number 17. The waker clone from method now avoids unnecessary clones when 2 wakers are assigned to the same task. Wakers are used to wake asynchronous tasks when Rust code is being run inside an asynchronous executor, so this makes the async executor more efficient. Number 18. The BufRead trait is now implemented for VecDeque U8, which is a double-ended vector of bytes. The decode UTF-16 iterator now automatically implements the FusedIterator trait when the iterator it is wrapping implements the FusedIterator trait. A FusedIterator is an iterator whose next method continues to return none forever after it has returned none once, instead of potentially resuming. Number 20. The IPv4 adder and IPv6 adder IP address structs have both gained methods for doing bitwise operations like and, not, and or. The actual list of trait implementations added is quite extensive, as you can see here. This is super useful for dealing with network ranges and masks and things like that, and should make Rust much more attractive to folks who need to manipulate IP addresses. Number 21. The ExitCode struct now implements the default trait, and the default value for ExitCode is success. Number 22. The representation of the none variant of the option enum is now guaranteed to be 0 under certain circumstances for null pointer optimization. Under those circumstances, it is safe to transmute a 0 value into a none variant. See the representation section of the option documentation for more details on those circumstances. A link is in the description below. Number 23. Documentation for when atomic loads are guaranteed to work on read-only memory has been added to the atomics documentation page. This is important to know when you're dealing with read-only memory, since a lot of atomic operations will fail on read-only memory. For more information, see the atomics documentation link in the description below. Number 24. The documentation for thread local storage initialization now makes clear that if a thread local storage initializer depends on itself, it could cause not only infinite recursion, but also aborts or panics. Number 25. On Windows 10 and later, sub-millisecond sleep is now supported. On older versions of Windows, you're still stuck with millisecond resolution for sleeps. Number 26. There was a subtle bug in the iterator returned by the stir type's split inclusive method. It was returning a double-ended iterator that could return slightly different results iterating backwards than if you iterated forwards and reversed the results. This has been fixed. Number 27. There are some platforms that are not Unix but still return true for config Unix. For example, the Nintendo Switch or PlayStation Vita. Now code like exit status from raw 0 success has sensible Unix-like behavior on these platforms. Now it's time to go through the stabilized APIs for this release. Number 28. All the atomic types have a from pointer method which stabilized. And here are all those types. They are analogs for most integer types, plus the bool and pointer types. The from pointer method takes a pointer and creates a reference to an atomic type out of it. Number 29. A bunch of file time related things have been stabilized. Let's go through them. First up, there's the file times struct. This struct represents the file times common to most platforms like created, modified, and accessed times. Next is the file times ext extension trait used to extend file times with platform-specific behavior. So far, there's only an implementation for Windows which adds the ability to change just the file creation time. Last, the file struct gains two methods. One that lets you change just the modified timestamp of a file, and another that lets you change all of the file times of a file at once. Number 30. The IpAddr enum and the IPv6 adder struct have both stabilized their toCanonical method. This method converts the IP address to an IPv4 adder struct if the address is an IPv4 mapped IPv6 address, and otherwise returns the IPv6 address. Number 31. The option enum stabilizes two methods to return a slice or mutable slice of itself. The sum variant will return a slice of length 1, and the none variant will return an empty slice. Now we've got a handful of APIs that were already stable, but are now available to use in const contexts. Number 32. IPv6 adder's to IPv4 mapped method has been const stabilized. This method converts an IPv6 address into an IPv4 address if it is an IPv4 mapped address. Number 33. Maybe uninit has had two methods const stabilized. The first is assumeInitRead, which assumes the value is initialized and reads the value from the maybe uninit container. The second is zeroed, which creates a new maybe uninit in an uninitialized state with the memory filled with 0 bytes. Number 34. The mem discriminant function has been const stabilized. This function returns the value that uniquely identifies an enum variant, aka the discriminant. Number 35. Mem zeroed has been const stabilized. This function returns the value of a type represented by all 0 bytes. Now it's time to go over changes to cargo in this version of Rust. Number 36. If you use cargo new to create a new crate inside a workspace, that crate will now be automatically added to your workspace config file, so you don't have to add it by hand anymore. Number 37. You may now omit a version from your cargo.toml file. The lack of a version number disables the ability to publish a crate. This is a step towards introducing cargo script functionality to cargo, where you have a Rust crate in a single file that you can run as if it were an interpreted script like bash, but interpreted by cargo, of course. Number 38. When running cargo doc, the full path to the documentation is now always printed out. This is super nice when combined with the next item, which is number 39. When cargo is omitting the path of a file in the cargo doc command, or when you add the -- timings flag to a cargo command, it will now attempt to create a clickable link out of that output, if your terminal supports such a thing. Number 40. If you are trying out the unstable cargo script feature, you can print out the values of the environment variables passed to the build script by adding the -vv flag. Number 41. rustc, the tool invoked under the hood by the cargo doc command, now accepts less invalid Rust code. This is part of an effort to decrease the amount of crashes in rustc when run with bad Rust code. Number 42. When documentation for an enum is generated, if the enum is C-like, meaning each variant is a unit type with a chosen constant as its discriminant, then the discriminant is now displayed in the documentation. It looks like this. Here, our enum A has variants A, B, and C, which have no associated data, only a chosen discriminant value. Therefore, the documentation shows the values 12, 13, and 1245 for each of the discriminants after an equal sign. Now for some compatibility notes in Rust 1.75. Number 43. Rust 1.75 now requires FreeBSD 12 or higher if you're using FreeBSD. FreeBSD 12 was released in 2018. Number 44. All of the MIPS targets that had Tier 2 support have been demoted to Tier 3 support, since no one came forward to address CI breakage required to keep Tier 2 support for MIPS. The demoted platform targets are listed here. The remaining MIPS targets were already in Tier 3, so now all MIPS targets have Tier 3 support. Number 45. The invalid alignment lint has been promoted from a warning to an error. Memory alignment is important, folks. Number 46. The compiler was not detecting references to packed unsized fields in some cases. This has been fixed, and the proper errors are now raised if you create a reference to a packed unsized field, which would mean pointing to unaligned data in memory. Number 47. The compiler plugin support in unstable versions of Rust has been deprecated for 4 years now and has now been removed. Time for new Clippy Lints released in Rust 1.75. There's only 7 new lints this time. I guess things have calmed down for the holiday season. Number 48. Unused enumerate index is a new warn by default lint that checks for calls to enumerate that ignore the index that enumerate returns. You might as well not call enumerate if you aren't going to use the index. Number 49. Unnecessary fallible conversions is a new warn by default lint that checks for calls to try into or try from, where their infallible counterparts into or from could be used instead. For example, converting an i32 into an i64 can never fail, so there's no need to check a result. Number 50. Waker clone wake is a new warn by default lint that checks for code that clones a waker and immediately calls wake. Instead, just call wake by ref and skip cloning the waker. Number 51. Struct field names is a new allow by default lint that you can opt into that detects struct fields that are prefixed or suffixed by the same characters or by the name of the struct itself. It is better to put the shared information in the struct name rather than in each of the field names. Number 52. Into iter without iter is another allow by default lint that you can opt into that checks to see if you implement the into iterator trait for a reference to a type, but you don't provide an iter method on the type that takes the reference and calls into iter as is customary. Number 53. Iter without into iter is another allow by default lint that is exactly the opposite of the last lint. It checks to see if you provided an iter method for a type without implementing into iterator for a reference to that type like is customary. Number 54. Manual #1 is a new warned by default lint that checks to see if you are calling build hasher and then calling hash exactly once and then calling finish, and tells you that you can just call #1 instead and do that all in one step. That's it for today, folks. Like and subscribe if you want more videos like this.